Hi guys, welcome back to our third online lesson for maths. Again, we're on perimeter, area and volume, and we're over across to page 77 today. Now what we're looking at today is we're looking at our cylinder, our cone, our sphere and our hemisphere, and then once we're finished that we're going to pop over to hopefully getting done question 3.1 and continuing it on in our next lesson. So to keep these lessons nice and short, to give you loads of time to practice. Now on page 77, what you're going to see, or even better if you can open your log tables, have a look at your log tables, open page 8, 9, 10 would be going on to now, and look at your formulas that's given there, okay? It's very, very important. Now, we're going to start off here, we're going to go formula by formula, cylinder, cone, sphere, and hemisphere, and looking at each of these formulas that's given to you. Now, to start off, let's look at our cylinder. Now, we have two formulas here for our cylinder. We have the formula for our curved surface area, and also we have our formula for our volume. Now, I want you to note down for yourself, either on your notes or in your own personal log tables, when it says A in your log tables, okay? So if you're looking at the formulas there, you'll see A equals, and you'll see V for volume. A actually refers to the curved surface area. You'll see it noted on the top right hand corner of the page on the English section, okay? Just be very, very careful. It's not the total area of the shape, it's actually just the curved surface. So for example, the cylinder, like around this section, you still have to get the total surface area, you need the circle on top and bottom also added on, okay? And we'll see that when we get over to question 3.1. Now looking at this cylinder question here, so we're looking at the curved surface area. So I'm going to look at the curved surface area and then the volume. So just to point out, not the total surface area, just the curve, using it here. Now I have my cylinder here, you can see the height along the side, think about a Pringles box, up how tall it is, and you also have your radius here. Now I might say to you, for example, I'm going to start my curved surface area, I'll say my height, let's just say is 10. My radius, I'm going to say is 8. Just going to pick two random numbers, and I might use the units. Maybe I'll use meters this time. Keep it simple, okay? So all in meters even. I'm not going to note it in here. You can note it in yourself. So I'm going to find the curved surface area, and I'm going to find the volume. I'm going to use the calculator a little bit because my brain is kind of slowing down towards the evening here. So here, to start off, I'm going to use 3.14 every single time for pi, or you can use your pi button on your calculator. So here, I'm going to fill it in to find my curved surface area. 2 times 3.14 times the radius, which in this case is 8, times the height here, which is 10. Pop this into my calculator, so 2 times 3.14 times 8 times 10 times 80, because I missed one. So here, in my calculator, fraction, I'm going to change it to decimal form. What I should get out is 502.4. Now, it's curved surface area there, so my units is meters, and because it's area, it's going to be meters squared. Now, onto my volume here for my cylinder. So again, the same idea applies. Fill it in, 3.14 times the radius is going to be 8 to be squared times the height, in this case, which is 10. Same idea applies. Once I've filled in correctly and I'm confident, plug it straight into my calculator. So 3.14 times 8 to be squared times 10. And what I get out, again, make sure you put it in decimal form. What I have here is 2009.6. Units wise, it's going to be meters, and because it's volume, it's going to be meters cubed. So be very careful to use the correct units. Here's my answers. So line them out quite clearly for my examiner, and that's my answers got. Now the next shape I'm going to move on to is the shape of a cone, okay? So be very careful if they say they use a word like cone, make sure you sketch it out for yourself and mark in the points that they give you. So here the same idea, I'm going to look at the curved surface area, so not the total, and the volume. Now the curved surface area for your cone is that kind of curve around here, okay? So think about the curve. here we have both, and look at your log tables, okay? You have the height and you have the length. Now, with regards to the height is the perpendicular height. So maybe just highlight it, circle it. H refers to the height, and that is the perpendicular height. When you see the letter L, that is the slant height. Okay, so be really, really cautious the difference between the two of them. Now, if in an exam you were given one and not the other, okay, so let's say you were given the height and you needed to find the length, you can always use Pythagoras theorem there. So just maybe jot that down the side. So c squared, your hypotenuse squared, equals a squared plus b squared, okay? So just if you ever get one and not the other and you need it, Pythagoras theorem is the way to go. So here our radius, I'm going to pick a few random numbers, I'll keep them nice and neat. So here let's just say my height is, I'm going to say 22. I'm going to say my length is 25. And I'm going to say my radius, is 10. So just randomly picking out a couple of numbers. I'm going to start off by finding the curved surface area, again using 3.14. Here, 3.14 times the radius, which is 10, times the slant height, or the length, L, which is 25. Again, same idea applies. Popping it into your calculator with me here. So 3.14 times 10 times 25. And we're going to get out 785. Again, let's pop back, no units given. We're going to pop down units squared. So 785 units squared. The last one here is my volume of a cone. So I have 1/3 pi, again I'm taking 3.14, times my radius, again which is 10, to be squared, times my height this time, okay? So notice h is the height here, so height which is 22. Again, same idea applies. Take out my calculator, 1/3 multiplied by 3.14 times 10 to be squared times my height, which in this case is 22. Now, not much space here left for myself. I didn't judge it too well, but my answer here is 2,302.6. Again, my units, I didn't write them down, so I'm going to say units. And in this case, volume is always cubed. Now that's the slant height, so not the total height as I keep repeating. Slant height, or apologies, curved surface area, apologies, not slant height, curved surface area, and also my volume here, okay? So my curved surface area and my volume slant height, apologies now, is here, okay? So just to confirm that. Now my next formula here I'm going to move on to is my sphere. So just think about a football, a Gaelic ball. That's what a sphere would look like, okay? So we're going to start off with our curved surface area and then we're going to follow with our volume. So all we are usually given here is we're given our radius. So I might pick here my radius. Again, I'm going to select something that I like myself. I'm going to select the number, I'm going to say 52. So I'm going to keep it quite big. I'm going to say 52, let's say, in this case, kilometres. We haven't used kilometres yet as our units. Now, the one thing about a sphere is the entire sphere is a curved surface area. So in this case, this is actually, the curved surface area is also the total surface area, okay? And it's the only shape in which it is. Now, when we're looking at our curved surface area, I'm going to pop it straight in. We have 4 times 3.14 times my radius, I picked 52, to be squared. So it's important to write everything down for our examiner, so if we make a mistake, they can see exactly where it was. So I have 4 times 3.14 times my 52 to be squared, plug it straight into my calculator and get it out. Now I got a really big number because I decided to go for 52. So we have 33,962.24. So I went for kilometres, so area is kilometres, and remember, always is going to be squared. So just keep that in mind for yourself there. The last one I have here is my volume. So here, total surface area, remember curved surface area, the same. It's the only one, unlike over here, that I don't need to add on one circle here and the area of 2 circles for my cylinder. Volume here, we're going to have 4 over 3 times pi, which is 3.14. Remember, brackets mean multiply, or I could use my multiplication signs, which is what I've actually been doing on my calculator, times the radius is 52 cubed, okay? So here, plugging it straight in, 4 over 3, multiply by 3.14, times 52 to be cubed, pop it straight into my calculator, and again, because I picked 52, I'm going to get quite a long answer. Here, I'm going to get 588,678 point. I'm going to go for 2 decimal places here. I'm going to say 8, it's 826, so I'm going to say 83, rounded up 1. Kilometers, and volume is always cubed, okay? Now, my final one here is a hemisphere, and a hemisphere is basically my football cut in half. So I'm just going to look at my volume for a second, but just remember, if we were looking at the curved surface area, it would be half this curved surface area, which is here, so multiply by a half, okay? And then a circle on top. So adding on my circle here. Volume, we're going to go straight into it. Again, I'm going to pick my radius, which I've noted in here. I'm going to say 15. So I'm going to say 15 meters, okay? So here, looking for my volume, how I plug it in. So here, 2 over 3, pi is 3.14. My radius is here, is going to be 15 to be cubed. Same idea applies, plug it straight in. I have 2 over 3 times 3.14 times 15 to be cubed. Pop it in. What we should get out is 7,065. Look for my units. My units was meters. It's volume, so it's going to be meters cubed. Now guys, that's a demonstration of all the formulas that's on page number 77. So what I'd advise you to do, if you're following along, you might pause, you might have paused in between each one and maybe taken down an example or tried it yourself. If you haven't, okay, it might be an idea now to pause the video, maybe take down the questions and try them yourselves and make sure that you can actually get each of the answers that I have on the board there, okay? Once you're finished that, what I want you to do is I want you to move across the page to exercise 3.1, okay? So exercise 3.1 on page number 78. And we're going to work through this question here. Now this question, I'm just going to grab my notes, is question page 78, as I said, and it is question 3.1. Now what we're asked on question 78, 3.1, we're asked to find that, highlight the word volume, okay? The volume and the total surface area, so highlight total surface area, given for the cylinder, highlight the word cylinder. And finally they say pi is 3.14, so just highlight 3.14 there. Now, what I'm going to start off with here is I'm going to start off with looking for the volume of this shape here. I'm going to then go on to my total surface area. So the first part, volume of the cylinder. Now, the second I see in my exam, they're looking for the volume of a cylinder. I open my log tables, I go back over here, and I look at the formula that they're giving me. Apologies. Formula they're giving me. So pi r squared h. So here, first thing I'm going to note down for myself is the formula of my cylinder. The formula of my cylinder is pi r squared h, okay? So there's my formula here. The second thing I'm going to do for myself is, once I see what the formula is, I'm actually going to go and I'm going to look at the diagram they give me and I'm going to label it. So I need to label r, which is the radius, and h, the height. So here's my radius, the distance from the center of the circle to the circumference, so this is r. My height is 30 centimetres. So they're all in the same units, just to note. It would be an important thing to note if they weren't in the same units. It would mean you'd have to transfer from one to the other. All I have to do from that moment on is basically fill in. So here, what I have for pi, they asked me to use 3.14 times my radius, you'll see over here is 5, to be squared, times my height, and although it looks the other way around, my height is 30, okay? Now, plug that into my calculator to get out my volume, and what I should get is 2,355, okay? Now, thinking back again, hashtag -1, we don't want to be getting that at all, so let's look for our units. So as you'll see over here, and you'll see on your notes, this is in centimetres. We're looking for the volume. Volume is always cubed, okay? Area is always squared, volume is always cubed. And that's my answer there, nice and clearly laid out for my examiner. Again, remember, if you don't get the answer right, the next thing, high partial credits, or it could be mid, will be for filling it in correctly, okay? So make sure you show your examiner exactly how you fill it in, not just writing down an answer. That's not what they want to see. Now, the second part of this question asked us about the total surface area. Now, they didn't say the word total, but that's what they're looking for. So the total surface area, okay? Now, often we refer to total surface area. I'm going to write it out, actually. So total surface area, oftentimes you'll see TSA, okay? Now the total surface area of this shape here, so be very, very cautious of this shape here. What you have is you have two circles, so the area of two circles, so I'm going to say 2 times the area of the circle, i.e. this circle here and this down here. So 2 of them, plus your curved surface area around the middle, so your CSA. Now, I'm going to fill this in nice and quickly for ourselves, but the first thing we do before we fill it in is we write down our formula. Now, our formula here, this is going to be 2. The area of the circle is pi r squared. So 2 times pi r squared, okay? So 2 times pi r squared, plus the curved surface area, which we looked at over here. Curved surface area we have here, 2 pi r h. So if we jump back over to here, you have it here, 2 pi r h. Now once you have that filled in, okay, or wrote down, you fill it in. So 2 times pi is 3.14, times the radius, which is 5, to be squared, plus, okay, so plus on the far side, 2 times 3.14 times the radius again, which is 5, times the height, which is 30. Now, once we do that, plug each side individually into your calculator. So this side is my area of the circle, the far side is my area of a curve. Plug this side in, what we're going to get out for the 2 circles is going to be 157. On the far side for our curved surface area, 942. Add these 2 together, so once we add them together, we get 1,099, and it's going to be, look at our units, centimetres, and area is always squared. Now guys, we're going to pause there on 3.1 so that you can actually go on to 3.2 and 3.3 and give them a go yourself. Now, prior to the next lesson, you need to make sure you have them done, and I'm going to start in the next lesson on 3.2. So give them a go before then. It's really, really important. Take that as your homework, guys. We'll see you later.